So this question comes from 9B and it says, assume the following situation can be modeled by a linear function. And it says, write an equation for the linear function and use it to answer the given question. And it says, be sure that you clearly identify the independent and dependent variables, then briefly discuss whether a linear model is reasonable for the situation described. The price of the particular model of a car is 18,000 today, and it rises with time at a constant rate of 910 per year, $910 per year. How much will a new car this model cost in 3.7 years? So in this particular problem, this is talking about, say I wanted to purchase a Ford Flex. And I know the prices are probably way off. But today in 2024, that model of a car is 18,000. But what about in 2026, in 2 years from now? If I buy a new Ford Flex in 2 years from now, the base price changes, right? It increases with inflation. So here we're talking about new car and how the price is going to go up potentially. There are some problems that you're going to see in these sections in chapter 9 where it's talking about a used car and the price decreasing per year. So you want to pay attention. Does it say increasing or does it say decreasing? Because that's going to make a big difference in the problem. So rises or increasing with time, that means it's a positive slope, a positive value. When we are looking at this, the two, let's pick out the two variables. The price of the car. So the price of the car, that's one variable. And then the time. How much will it cost in the next year? So we've got two different variables. And let's write those out. We've got price and we've got time. So the price is going to depend on the time. The time doesn't depend on the price. So this is always y depends on x. So the price depends on the time, how much time has passed. And remember the y is my dependent. So we're going to say the price is dependent. And the time is the independent variable. And they ask us to call, and it actually tells us that in the question. They say call independent variable time, t, in years. And they say call the dependent variable price, p, in dollars. And then they ask you to write the linear function. So to write that linear function, on our formula sheet, we're going to see this. And we've got it written in two ways. We've got this y equals mx plus b. That's in math terms. Or we have it written in a phrase that looks like this. Dependent is equal to the initial amount plus the rate of change, or slope, times the independent. And what I want to point out to you is that this is the same thing as this, but this is written in words. And yes, I did write it backwards. Really, the matching phrase would be B, this is the initial amount, plus the rate of change times X. So let's pick out what we need from here to write our linear function or our linear model. So dependent, they told us to use P for price. So I'm going to say P is equal to the initial price. So the car initially is $18,000 today. The rate of change is how much is it changing, that constant rate. Remember in the book it talks about a constant rate. And when you have a constant rate, that's when you have a linear function. So a constant rate, 910 per year. So 910, and that's going to change 910 times the number of years, so times t. So you would write it like this. The dependent is the p, and the independent is the t. Next, it says find the price of the car after. How much will a new car cost in 3.7 years? So that means that I'm going to take my linear model and I'm going to plug in for the number of years. Remember, the units are years. It goes in place of t. And so I'm going to put that in my calculator. And so I can put this all in one line. I can say 18,000 plus 910 times, is it 3.7? 7, and then hit enter, and this is the answer I get. So then the price of the car after 3.7 years will be, and I'm going to write that down here, and my units here would be dollars, so 21,367. Now, to discuss, is this reasonable? The, I would say it's probably, reading all those statements that they give you, it's likely that a new car model will increase. So we can kind of rule out the decreasing or never changing because we kind of see an increase all the time. But does it, so then that leaves us with 2. And it's unlikely that it'll increase at a constant rate or that it increases at a constant rate. And I would say it's more unlikely. It's unlikely it's going to be $910 every year. It would be more likely that it would probably be a percentage every year, but it probably is going to vary. And it's not necessarily going to be $910 increase in price. It's not that constant typically when you're talking about the price of goods. Sometimes, I mean, just look at a price of something that you're used to buying. Maybe you're used to buying a gallon of milk and you'll see an increase. Sometimes you see an increase, sometimes you see a little bit of a decrease, sometimes you see an increase, but is it always 10 cents every year? No. Is it is it always a certain number? Is it a constant rate? The answer is probably not. It's probably, maybe it goes up 10 cents this year and maybe it goes up 12 cents next year. So that's what they're trying to get you to say, is it reasonable? Is the linear model reasonable? And I would say probably not. And that's how you do this type of question.